Cool. So I was like spying on some of you from the various nooks and crannies of this theater while that talk was going on. I see some of you just kind of fidgeting with the Google Cardboard, like, I want to play a simulator, I want to play a simulator. But VR is actually only one part of the cool stuff happening on the web. Like the other side we should consider AR, right? Like that's pretty cool. And we're pretty lucky here today to have an AR expert, the one and only Zeno Rocha from LifeRay. He's a developer advocate there, and he's going to tell us all about augmented reality in JavaScript. So please give it up for Zeno Rocha. Thanks, guys.
Yo, tell you what I want, what I really, really want. So tell me what you want, what you really, really want. I'll tell you what I want.
What can be better than Rick and Martin, right? Spice Girls. Yeah, so today we're going to talk about crazy computer vision stuff in the browser. And I know exactly what you're thinking right now. It's like, computer vision in the browser? Okay, I'm gonna get some coffee, see you in 30 minutes. And I know what you feel like. This is not something that I'm gonna use in my jQuery code here on this little project. But there's actually a lot of valuable lessons on it, and it's basically, it all comes down to HTML, JavaScript, and CSS. And that's what we're gonna see in the end. So here's my Twitter handle if you want to send any questions, if you have anything on your mind you want to share, when you ask, just send me a tweet, and I'll be more than happy to answer you. I work for LifeRay. It's a company that we build open source portal solutions for enterprise companies. And it has nothing to do with what we're going to see in this talk. I'm originally from Brazil. So I guess I'm probably I'm the only people from South America here. I don't know. No? Another one? Cool. That's awesome. Yeah, there's a lot. Yeah, so I'm from Brazil, you know, like soccer, that's so cool, right? Carnival, Rio, beaches, and World Cup. It didn't work so well for us. But now I live in LA, like Hollywood stuff, stars all the time, city, Disneyland, so awesome. And I'm extremely, extremely happy to be here today in Stockholm. It's my first time in Sweden, and you know I have been hearing all those amazing things about Sweden. You know, like baking stuff, Ibrahimovic, like Spotify. So it's pretty cool. I'm really happy to be here. And my idea with this talk is for you to live like this. That's basically my idea. If you leave my talk like this, I'll be like pretty happy. So what's computer vision in the end? You know, what does that mean? And it basically is having my computer to see something, right? And we have webcams, so we can probably do that. But first, there's some concepts that we need to understand, like things like persistence of vision. And we all know that this is how our eyes work. So we have an object in front of us. The lightning from that object comes to our eyes. It gets inverted on the retina. And then, yeah, it gets inverted on the retina. And then that image goes to the optic curve nerve. And then it goes to the brain. And the brain captures that image. So that process takes like a fraction of seconds. And that's the phenomenon of persistence of vision. And that's how we do a lot of stuff with that, like movies. And by using that kind of thing, we can take advantage of motion perception. So motion perception is just lots of images that are like really, really fast showed to you, and then you think it's moving, but it's just like really, really fast in different positions. And what are the challenges, and what are the things that are under this computer vision umbrella? Face detection is one of them. So you have an image, there's a lot of pixels going on, and you need to identify somehow that those are faces on this image, you know? How can you say that? Like, a face is so different from each other. Like, one is smaller, another is bigger, and there's so many nuances, and it's pretty hard to do that. Another thing that is really, really challenging is face recognition, right? Can you recognize who is on this picture? Johnny Depp. So it's the same person, but in a different context. So even for us humans, it's pretty hard to tell who is this guy, you know? But it's the same person. And having a computer to identify that, it's even harder. And there's a lot of stuff like autonomous robots. This is their World Cup. So amazing. Yeah, so you put like a camera on a robot and then you start playing soccer. It's just incredible. Yeah. Yeah. This is like the Brazilian team playing, something like that. It's really horrible. Look, look. Oh my God. Tension, tension. Oh, that's amazing. So, like, this is computer vision. You know, there's a lot of things going on to make those robots work. Virtual reality is another topic. Like, you get something from real life, movements from real life, and then you put that on a virtual world. And the opposite of that is augmented reality. So, as we saw on Iron Man, like, you have the real world, you have the real image, but you start plotting virtual images and virtual reality stuff on this real world. So how can we do that? There's a lot of stuff. It's pretty challenging. There's some libraries that you can find on GitHub to accomplish that. One of those is R-Toolkit. They have a port for Flash Toolkit, and then they have JSR Toolkit, something like that. It's pretty popular. OpenCV, another pretty popular library in C++. But how can we do that in the browser? And that's what this talk is about. How can we do those kinds of things that requires a lot of computing, and how can we just do that with JavaScript? So if we're talking about computer vision, the first step would be accessing my camera, right? We want the computer to see. So fortunately, now we have HTML5, and one of the specs is the media capture and stream spec. So we can request the user's webcam using the getUserMedia API. We can ask for the video or for the audio from the user, and then we have those two callbacks on success, on fail, and you can run whatever you would like. So now that you got the stream from the webcam, we need to do something with this stream. So we can reproduce it on a video tag. HTML now have video. So on success callback, we can get the video, we can create a URL using that stream, and then we can put it on the source of the video. And then this video element is gonna run what's in your webcam. Then you get the pixel matrix. So for every single frame of that video, you're gonna get the pixel matrix. And you can do that using Canvas. And the last step is applying the tracking algorithms. And this is the most challenging one, for sure. So here's a recap. You access the camera, the user accepts it, of course. Then reproduce the camera in a video, you get the pixel matrix, you put it on a canvas, and then you apply tracking algorithms, and then you do something with those tracking algorithms. And that's what we did in this little library called Tracking.js. This project is like me and some coworkers doing that just for fun on our weekends during the night. It started with Eduardo back in Brazil, and we were together doing this, and it's been growing. It's like just JavaScript. It's on GitHub. We don't depend on any library. We try to do a really simple API, and that's what is pretty challenging when we're talking about computer vision libraries, because it's usually like C++ guys that they don't care about the APIs. Like, OK, I'm just going to run this really crazy algorithm, and I'm not caring about anything else. We put some tracking algorithms to make it easier to use it, and we have a lot of stuff. We're really obsessed about performance, and we have some performance regression tests. So whenever someone pushes code to GitHub, we see if this code is actually, it's not only about failing or like, OK, this code is working or not with unit tests. It's more about, is this code like slower? Like it can work, but is it slower or faster? How are things now? And it's only 7K when gzipped. So one of the first features of this thing is like color tracking, right? So we get the image, can be an image, can be a video, can be the webcam, and then we want to track colors on it, OK? So let's say we have an image like this. So this is just an image on the web, and I want to detect the magenta color. So I can go to the constructor, then ask for the magenta color. And whenever I track that magenta color, I'm going to just plot a square whenever I detect that. So I want to detect cyan as well. OK. So this is basically what color tracking is on a regular image. And the API is like ridiculously simple. So you have a constructor called color tracker, and you can pass some colors like magenta on this case. You have a selector to tell what is the image that you want to track. You apply that object that you created, and then you have this track callback that is triggered when there's something detected. And when you have that, you can like draw a square or do something really crazy with that. So one thing is color tracking. The other thing is like object tracker. And you can track other stuff. Like imagine you have this photo. So we have a lot of pixels going on. We have some people, and I want to track their faces. So I can probably come here and tell face. And now I track the face. And I know what you guys think, like, OK, I saw this on Facebook, and I saw this on other websites. But imagine if your boss like comes to you tomorrow and say, hey, we need to apply this on our website. It's like it's pretty challenging to do those kinds of things. And we can also track other stuff, like mouth. Crazy, right? Cool. OK, that's interesting. Or you can track not only images, we're just tracking images here. Let's track our webcam. Cool. So what is the API for using the camera, for example? Pretty similar. You have the object tracker constructor. You can pass some value like the face, mouth, eye, and then you put the selector, like some kind of video that I have the video tag that I have on my page, and then I have this option camera true, which then requests the webcam, and then we have the callback. And once we have the callback, we can draw a square, we can do whatever we want. And you can also build your custom trackers. Like imagine you want to track car plates. For some reason, you want to do that. So the API is pretty simple too. With ES6, much easier. But you can just inherit this constructor, and then you implement the track function, and you send an event when something happens, a track event. Cool. So who's using this kind of things? There's one project. I love this one, by the way. So they detect my face with tracking.js, and then they put some fire, and I can record it, do some crazy stuff, and convert to a GIF. And I can publish. I love this one so much. Cool. There's another project like they detect your face using tracking.js, and they put some Slipknot mask on you. It's pretty awesome. I check it out a couple hours later. It's down, offline. I don't know what happened, but it's pretty cool. And we learned a lot of stuff doing this thing. We were like just building websites, just building like JavaScript libraries, frameworks, and doing our stuff. And this was like completely new for everybody. So there's a lot of things that we learned. And the first thing is like doing something that is really, really fast. It's pretty challenging. Like doing something in 24 frames per second, which looks fast enough. But if you try to make it better and faster, like 60 frames per second, like you can see the difference, right? It's important to spend some time doing that thing. And if you just want to do something in 24 frames per second, you have like 41 milliseconds per frame to run your code. So that's pretty challenging, especially if you want to track faces, colors, and those kinds of things. And like we are used to 24 frames per second. But like remember when you watched The Hobbit, the latest movie? Like everything was like different. What's going on, you know? And that's because they were filming with more frames per second, and it feels like faster or more real life than it is. And one of the algorithms that we use to track faces, it's called Viola Jones, and it's basically like you need to scan every pixel of this image, and like this goes. Like this is a really slow motion, just to show how it is to detect a face. But then it's going to run and like try to identify the patterns and do all those kinds of stuff. I learned about typed arrays. I never used it before. Like int32 array, float 64, and I learned how they could be like faster and more performant. So what is the difference of having a bidimensional array or not using an array at all, or using int32 array? In even like math operations, there's a lot of performance difference in math operations. Like, should I use sum or should I use multiplication? Sometimes you need to choose between of those things. So with color tracking, you can do a lot of stuff, and you can do like tracking colors on a video, like this. Like tracking, on this case, we're tracking yellow and magenta, I guess, cyan, and some other colors, yeah. There's even like some other algorithms. This one is called fast. It basically tries to understand the corners of some image. You can do that like for tagging friends, those kinds of things. although it only does face detection and not face recognition, which are different. And you can go really crazy. You guys remember Draw Something? That game? So you can build something like that. If I get some magenta color, so I just have an object like this. It's the Polymer logo. And not like this, but should be a Polymer logo. And they have magenta on this part. So maybe I can draw the Nordic.js logo using this. You can go really crazy, seriously. What else? I can track yellow colors. And I can get this lightsaber over here and track the magenta color of that. Do some crazy shit. Really. I can also integrate with Tree.js. So I can detect the magenta color again and interact with a Tree.js scene using that. Come on, that's insane, right? That's insane. Oh my gosh. Oops. What else can we do? And not only color tracking on a 3D scene, WebGL, Tree.js, but you can try to do that with face detection. So I can move around on this scene. That's so crazy. That's so insane. And this one never works, but I'm going to try. It never works, really. So we tried to put that on a game. And we built this crazy control here, red is brake and the other ones is use to turn. This is not going to work, I'm pretty sure. But let's try. Where's getting red? There's no red here. Yeah, but the idea is that you would control the game like this. But I'm a horrible driver. You can do all those crazy things. And, right? Did that work? That worked? And if you think about it, you can even integrate this kinds of stuff with web components, which I like a lot. And how we create web components nowadays, or any component. First of all, you just use a plugin, right? You don't create components at all. So you go, if you need a carousel, you search for carousel plugin. And if there's a list of the 30 free responsive jQuery carousels lighter plugins, you go there and you get the first option. You copy and paste their code. You don't have any idea what's going on. And you hope it works. If it works, awesome. So that's how we create components nowadays, right? And with web components, there's a lot of different specs that help us nowadays, like custom elements, shadow DOM, HTML imports. And you can create any kind of component, right? So I created this Nordic.js component, which is basically this thing. And what this component does, pretty much nothing. But if you turn off the lights, maybe it does something, I'm not sure. Can we turn off the lights? Can we? That's black magic. If we turn on again, stop. Black magic, really. And that just like a tag in your page. So that's how web components work. It's not the topic of this talk. But remember this thing? Like you had a constructor, you had like some options, the element that you want to track, camera, and then you have a callback. You could do all of this using web components under an HTML API. So you can use a regular video element. You can use the is attribute to define that this is a custom element that I'm extending video. And you can create attributes like target, magenta, camera, true, on track, call some function. And you could create some kinds of things. That's pretty crazy. If you want to learn more about all those crazy stuff, you can go to trackandjs.com. There's a lot of documentations. All those demos that I showed you, they're over there. And like, this is pretty cool. And I'm so happy that I'm here today. And it's nice, right? Like, we are doing our stuff in our house or in our offices. And some are using React, some are using Angular, some are using Polymer or whatever you're using. And we're like on our comfort zone doing our stuff. But the simple fact that we are here today, we're trying to come to this place, like where the magic happens. And just by sitting here, we're not actually going there, but that's the first step. And that's why I'm so happy to be here today. So that's it. Thank you, guys. Thank you.
Thank you so much. I know I said no questions, but I have to cheat a bit and ask you one. What is the mobile support for this stuff?
Yeah, so the mobile support depends on lots of stuff because we're using different APIs.
Right.
So it really comes down to like, what is the support for get user media? And then you check it out if iOS, Safari, it has support, or if Chrome for Android has support, and Canvas in those typed arrays. So it's really mixed. We don't have like a matrix for that.
Sure.
Because this is like just something that we are like, okay, let's make this thing pretty cool, and we're not caring so much about like production level or making this work on mobile too
But then
much.
like getting access to the phone's camera.
Yeah.
Yeah. Can you do that on? I know you can on iOS.
Yeah, we can do
can?
that with get user media. Yeah.
Really? Oh, cool.
Awesome. Cool.
Learn something every day. Thank you so much, Zeno.
Thank you.